Hello.
So I'm very pleased to welcome Heinrich Stamerjohanns. I hope I've not butchered his name. So Heinrich Stamerjohanns from Germany. He did a PhD in physics at Oldenburg University. He taught computer science in Bremen. And now, if I understood well, you're a software developer.
Yes.
You worked on the ArchiveML project. You will tell a few words about it, but that's not the main focus of your talk. You will mostly speak about Texmlbus that is supported by Overleaf. I will pass the URL of your GitHub repository in the chat, and now we can listen to you.
Okay, thank you. Okay, now you should see my screen, I think. And yes, so I'll talk about Texmlbus, which is a build system for LaTeX. So first, I will shortly talk about LaTeX and XML, and then I'll demonstrate quickly the build system. So why do we need XML anyway? Because LaTeX is the format to write math, and millions of publications have already been written in LaTeX. And as we all know, it's still the best way to produce high quality math. But there are some drawbacks with LaTeX. It mixes form and content. There are no real semantics with it. And something that we have faced in our ArchiveML project, which I will shortly talk about, style files change over time, and that is a problem. There is no formal validation for LaTeX, and if you want to recompile all these maths in 30, 50 years, it is not really clear whether this will still work. So on the other hand, there is XML. XML is, of course, something you do not want to directly edit, as you can do it with LaTeX. But there are some advantages. Such a document can be validated, so it can be used as a possible archive format. And one format is, for example, JATS, the Journal Article Text Suite. There are some other dialects of XML, MathML, for example, or XHTML. And with these dialects, you are able to directly render documents in a web browser, for example. And for searching and indexing tools, and as we have seen for screen readers, it is a lot easier to work with XML instead of LaTeX source code or PDF, for example. So some years ago, we did this ArchiveML build system at the Jacobs University Bremen. There we tried to convert documents from the archive preprint server into XML, and we used latexml to create XML with that. And for that, we needed some kind of build system to do mass conversions into XHTML. At that time, we converted approximately 500,000 documents. And the reason to do this was to have some real-world MathML documents. And another reason was to improve latexml, which was under development and is still under development. latexml is some software which is written by Bruce Miller and Dejan Djinev. And Dejan Djinev also has the successor of the ArchiveML build system. It's named Cortex. that system is being used to do mass conversion to XHTML. So the system we have written at that time at Jacobs University was written in PHP. It used SQL database to store some state and distributes jobs on several hosts. You also need to set timeouts for each host or for each job, because there are possibilities where some conversion jobs can run indefinitely. So what the build system then does is it checks the files that have been created. It parses the result files, for example, stdr.log, and then it tries to classify results and stores information in the database. So what I'm talking about now is Texmlbus, which is based on archive.ml, but Texmlbus changed the focus a little bit. This archive.ml tool was free software, but it was like not really easy to install on any other machine. And you had to have some knowledge to actually work with it. So one of the changed focuses is to ease installation, to provide more interactivity, and also to be able to produce other formats than just XHTML. One possibility to produce other XML text, but actually to support any other format which you can run through a converter using LaTeX as a source code. And you should also be able to create the same target, for example, PDF, using different systems. So you could use an older TechLive, like TechLive 2019 against TechLive 2021 or something. So to ease installation, I switched to Docker images, which allows to install this on any main machine like Apple's, Unix, or Windows. More interactivity. First, it was run just by some commands. So now it should be possible to upload files via a browser or import files directly from Overleaf, or just provide a directory and scan all the files in that directory. And it should be possible to schedule conversion jobs via browser, for example. So other targets than XHTML, that was a little bit more complicated because now it was needed to have result tables and store a lot of more state for each possible target. And then create same target using different systems. For this, I introduced stages, and that is actually a target combined with a specific image that is being used. Image is in the term from Docker, so you could see this like as a system. So a target that is combined with a specific system that is called a stage on Texmlbus. And for this, you need to have subdirectories for each stage. This was implemented by using hard links, so you do not need to copy all the data again and again, but by using hard links on the directory, you kind of create copies, but you do not need space or additional space for this. So this is a simple overview of the system. It consists of several different parts. On one hand, you have the document files. which is just basically a big directory with subdirectories for specific sets or for specific articles. Each article needs its own subdirectory, and these files are shared among the build manager that I will talk about a little bit later on, and the converters that are being used. Then there's the SQL database, which stores state. So it can also create statistics about everything. And then there is the interactive usage via browser. So typical things, you can add and remove documents, you can queue conversion jobs, and you can manage document files. So provide style files and things like that. So then there's a build manager, which operates on the work queue, and this build manager schedules then make jobs on so-called worker containers. The worker containers are the like systems that do the actual conversion of files. And later on, this build manager analyzes log files that have been created. And then we have worker containers. These containers are like a full system that run some specific converter. So typically, as we use latexml, we call latexml and latexml post to do conversion commands, but we can actually add any other converter that should be used for this conversion. So what happens in this system, the typical way is you add documents to the system, you queue a conversion job, and then these documents are added to the database, not full documents, but rather like metadata about the documents. Like, where is it located? When was it added, and stuff like that. So the build manager then reads this work queue and queues conversions then, and invokes, for example, make, because we're using make files to do the actual conversions. And then on these worker containers, latexml, for example, is being called. The conversion takes place, creates result files and log files. So result documents are being created. And then this build manager reads these log files and tries to analyze the result. For normal make files, this is just like success or failure, and we have different steps in between. So we could like create the document, but there might have been problems in the conversion. And so these log files are analyzed, and common errors are like parsed and found and put into the database. So a possibility is to like that there are missing macros, and this can be analyzed and stored there as well. So to put this or to convert the whole system into a Docker system, you can analyze what is responsible for what. So we have like a MySQL database, a web server running with PHP and converters. So you actually need to have 3 Docker containers and a shared volume. And If you're interested in Docker, this looks like this. Then you have Docker Compose, which coordinates all these containers. There's a MySQL database, the build system, and one or several workers which do the actual conversion. And they all use the shared volume where the articles are located. So now I just give like a simple introduction into the build system, how it looks like in the browser. On one hand, you have an overview over the statistics, or you can see you see my mouse button?
Yes, we can see it.
Yeah, okay. So you can see here like different targets which I want to create, like PDF, XML, XHTML. And for each target, I can see the statistics. So in this like simple example, which is like the sample set, which can be easily created using create sample set. There are just 5 documents, and you can see if you do the conversion to XML, 4 documents are okay, 1 document has an error. And you could also like click, and you can see like the detailed return values. And so this document has a missing macro, for example, and you could click on this link and find directly the error message that that has been produced for that. So the typical things would be, first you need to get files into the system. So you can upload and import articles. You can import simple articles or typically zip files containing multiple articles, and you would just drop them here and import them into the system. You can specify a set because to make it easier, you can like organize articles to specific sets, make it more easy. Another option would be to directly import articles from Overleaf. So you could again specify a set where you want to add the article to. For Overleaf, each project has an ID. You would need to specify the numerical ID, and then you can provide an own project name for the article, because you probably would not want to use the numerical ID for that. Then you need to provide your username that you have there, and then in a pop-up, you need to provide your credentials to import articles. So here's like one simple article. This is actually the presentation that I have done. There are some missing macros when I use the tugboat style file, and I could change my article using Overleaf, and I could update this article again and export this again into XHTML, for example. Here you can have like an alphabetic overview over all these articles. You can see here on the left, I have several sets, an overall set which combines all sets together. Samples, like all the samples I'm using right now to test the system. And again, I can see all the possible targets that I have right now, and can see the current state of these articles. And what is helpful with the build system is by just clicking on the links that you can see right here, I can directly get to the source code of the document. So it's probably not readable, but I hope you can identify this as, you can see this is text source code. So I can just go back, click on a linked dest file. No, click on the XML dest file, for example, and you can see the XML document that you have just created, that has been created. Or I can click on the PDF dest file and see the PDF document, which is now a sample document. And this is how I can quickly go through all these different things I want to see. So let's see whether I can change to this screen. And now you can see this is the live document, the live system now. You can see localhost. It's just several containers running on my local system. And there I can quickly get to the destination and error codes. So I do not need to use comments to get there and to see any problem. I can quickly find problems by just clicking on the documents. And this is really helpful if you have 50, 100, or 1,000 documents that you would like to convert. So let's see. So here I have some sample documents, and you can directly see the created XHTML, which is being rendered then in the browser. And you can see here that this all is actually XML code that renders the math. This is MathML, which works quite well in any typical browser right now. So Firefox, for example, directly supports MathML, and some other browsers like Google Chrome use JavaScript to actually display the documents in a browser. So what else can I show here? So yeah, here you can see the different possibilities. I could upload files, or I could scan directories for documents. I can upload class files, or I can install class files. Some typical style files that are being used can be directly imported, which are not typically available in TechLive systems. And let's see. So one other possibility is if I want to change documents and create XHTML out of this. Here you can see my presentation for as it is supposed to be written. Then you can see here like the document, and you can see right here there's some missing macro right now. So one possibility is to change this document directly in Overleaf, for example. I just write hello XXX, recompile, and so it has been automatically added to Git. So if I go back here, I can update this document in my system. So this has been updated. Now I need to queue this file again for conversion. So it takes some time. And if I click on the dest file now, you can see right here, now there's the new hello XXX, for example. So it's a really easy and quick way to create new XHTML, for example. So let's go back to my talk. So I can also like collect statistics. You've seen this already in the one slides. Here you can see like general classes. So there's exception, error, success for some documents, and I can also find out about detailed return value. This can be also displayed graphically, so you can have an overview how some document collection is actually doing if you do conversions. And these errors typically happen because latexml also needs to have like some semantics. You need to have special latexml binding files to do the conversion to XHTML. And it is always possible that some style files that are being used are not fully supported. And therefore it happens that you get errors there. So the Texmlbus system allows you to convert documents, and you can gather statistics about the conversion. And it is really helpful if you want to do comparisons, for example, between some older system and newer system, because you can then easily detect regressions with real world documents. And these stages that are being used allow you to have the same targets using different systems. You can, in this example, I've not demonstrated this, but you could have like 2 PDF stages, for example, where one PDF normal, for example, would use TechLive 2019, and PDF Edge or something would use TechLive 2021. And you can also run hundreds, thousands of documents and gather statistics how well this is being done. For this system, we typically use latexml because it seems to be, or not, it seems it is a really good converter to XHTML. But actually, you can support any converter. What you need to do is you need to have some Docker container which understands some comments that you can send to. Currently, this is all being done via some HTTP API. And you also need to write a simple analyzer that analyzes the log files, which is not too difficult. And then you can plug in actually any converter that you would like to use. Yeah, I have some time, so I can talk about like this one example you might have seen here. Here you can see there's one stage called page limit. There was an article like 1 year ago about people trying to sneak some page limits if they submit papers to journals. and some typical comments have been identified that are being used to do that. And so this page limit stage is actually a just simple stage that looks for these comments and then tries to find out whether some circumvention comments have been used or not. Okay, so yeah, any converter is can be used. So what needs to be done currently? Converters should be added more easily. It used to be like that you could just use any container, and what needed to be done was to be able to SSH into the container and run some command. But I took this, I changed this because you always need to have some private keys for that, which is actually not a real problem because you have just limited access to these containers. But typical automatic parsers that parse such Docker containers, they always give some warnings. So I have switched completely to HTTP to externally run these containers. So this needs to be added if there's like some container that can be used for conversion. And what also needs to be done is to help to improve latexml, to have sooner or later full coverage of all LaTeX comments and style files. Yes, that's it.
Thank you a lot, Heinrich. That's really conversion at an industrial scale. That's impressive. Are there questions? You can raise your hand or put a comment in the chat. To start, I have a naive question. Did you detect some unexpected bottlenecks when you compiled or converted 500,000 documents? Sometime when you start such a big computation, you detect that the file systems are not add a bottleneck to the process, for example, or the network. Or
when we did this conversion with 500,000 documents, that was actually like a bigger machine. I think at that time they had 16 CPUs. So that was not a problem. The bottleneck, or the biggest bottleneck, was time. So latexml is not like a super fast converter. So to convert that many documents just needs some time to do the conversion.
Okay, it was mostly CPU power and no other resources.
No, like okay. At that, like for that system, we had like one bigger machine, but we actually also used some other hosts where we shared the file system via NFS, and that was also not a problem at all. It's not typically a problem.
Okay.
And now all this, like this system right now hasn't been used for 500,000 documents or so, but currently it just, or you can, like if you use Docker Compose, you can only use your local machine. But if you have like several processors, you can easily start several converters, and that is runs well.
Okay. I have another question. In your process, you're carefully checking for conversion errors, but errors that are signaled by the converter. When you convert things, do you also do you have another process checking the result, that the result is consistent?
Yes. What happens is they share the file system. So the file system is also being used to do some simple signaling on the file system. So there's one file that when the conversion is finished, that file is just being touched, and the queue manager can automatically determine that some change is happening on that file.
Okay.
It's like a file system event that you can use for that. So watch that single file, and you can see the queue manager knows then, okay, something happened, and then the queue manager actually parses the log files. So the converters just do conversions, nothing else.
Okay.
Thank you very much for your talk, Heinrich. I found it very interesting. I learned a lot about cloud computing, which is new to me in concrete terms, and also about how Overleaf fits into the tech community and the tech ecosystem. The thing that strikes me is that your focus in some sense is not on doing things in the cloud necessarily, but on being reproducible. And what excites me about what you've done is that Don Knuth's ambition and success was to get identical outputs from identical inputs across space and across time. And the big problem we have is ensuring that things are identical, and the controlled environment provided by containers seems to be really, really good for that. So what's going through my mind is rather than sending the results of computations, we can send the thing to be computed. And that means we don't have to send large amounts of data about, we just have to send a formula. And the formula is the text source plus the secure hash for the environment in which it's run. And I wonder how well that fits in with your thinking and ambitions, if I've been clear enough to explain it.
So you mean the result document would be like the hash, like a hash of the result document to compare?
Yeah, rather than saying here's this big PDF, you say here's this small document, and when you typeset it, you should get this hash.
But what I don't really understand what would be the use for that. You can you could if you just want to know whether the result of one conversion is different to the other, you can of course compare these hashes to find out that they are different. But in this system, you also want to find out where are the problems. So where are the error messages? So what is actually also being done in the system is that each error message is being like classified and added up. So you can, for example, convert 100,000 documents, and then you automatically find out about the top fatal errors. So if you, for example, change something in a newer tech version, and you convert these 100,000 documents with a newer tech version, you might find out, okay, now 1,000 of these documents have this particular PGF ABC problem, which seems to be unknown right now. I don't know. And you can easily find out where the problems are if you switch from one version to another version, for example. And a hash would not be helpful for this.
The hash would be very helpful for telling you that there is a problem. It won't tell you what the problem is.
Yes.
And so if all I wanted to do was to check that my compilation of the document is the same as the author's compilation of the document,
then you can just use a hash, yes.
Yeah, and if there was a problem, then I could get from the author or elsewhere, presumably via a hash, a formula for constructing the document. And then I can have another go. Yeah, I think you've got a very definite purpose, which is supporting thousands of users on Overleaf. I've got a slightly different purpose, which is keeping things exactly the same. But I think the tool sets are, in some senses, got a large overlap. And so I found your talk very interesting and very useful. And well done for using cloud computing.
Are there any questions? Heinrich, I just answered a remark from Ross in the chat about the hash.
Yeah, that is of course a problem because some dates are different there. So you need to have like not a simple hash function which just hashes the file, but needs to know that this is a PDF file, and there are these dates which I need to take out.
Yes, it would be a hash based on the content of the pages and not the file itself. Yes, I guess.
There's a movement afoot for reproducible computing in all sorts of places. The most recent place I saw it is what's called the Squash FS, which is a read-only file system. And ordinarily it generates the Squash FS, which is a file system image, as quickly as possible. You can, but in recent versions, its default is to always give the same output from the same input. And anything such as putting the date into the document, of course, destroys that.
Well, not in the sense that the date is an input. If you put the same data, you will have the same output.
Yeah, and part of the input is the reading of the system clock. That's the problem. With tech on the command line, you can say, here's the date on which it is compiled. You can set the time variable in tech on the command line. And that's a way of getting reproducible outputs. That's a straightforward conflict between two needs. The one is reproducible computing, and the other is you want the document to say when it was made.
Okay, so thank you again, Heinrich, for your really nice work and the clear explanation you gave about it.